Hi, in this section, we'll be looking at the 38th problem in Project Euler. So let's see the question. Am I sound like a robot? Because I repeat the same things for every video. So never mind. So for problem 38, pen digital numbers, pen digital prime multiples. Take the numbers 192 and multiply it by each of 1, 2, and 3. We'll get this by concatenating each product. We get 1 to 9 pen digital. We will call the number a concatenated product of 192 and 123. The same can be achieved by starting 9 and multiplying by 1, 2, 3, and 4 and 5. Given the pen digital number, which is the concatenated product of 9 and 1, 2, 3, 4, and 5. What is the largest 1 to 9 pen digital number that can be formed by concatenated product of an integer with 1, 2, and so on to n, where n is more than 1. So we need to do the multiplication first. Okay, we start with 2 first, and then this is our string. So we'll go through the numbers from 1 to n and multiply and test whether the number is pen digital multiples or not. So this is the string. We will use it to concatenate the numbers. So what is meant by concatenate? It means that we fuse a number together, and for pen digital, it means the number that only exists one time. For 1, it only exists one time, and each of the numbers from 1 to 9 exists exactly once. So the number should be, the digits should be 9 digits. So first we start with the 902 first, then we will load until 9,876. Because larger than that, we will probably get the numbers that's more than 10 digits. So here we will move force times it by 1, 2 until the end, and we concatenate the string. Then we check for whether the number is pen digital or not. If it is not, then we do the operation for the next number. Then for the numbers here, 1 and 2. So I have encoding here if pen digital function. So basically it's a flag that indicates the existence of the number of the digits. So the question doesn't want 0, so we ignore 0. So this is count the number of unique numbers found in the number. So we will use long because long is 9 digits or so on will be insufficient for integer. There are some cases so I put long. You can put big integer but it's lower. So one number more than 0, I will get the last number. If the last number doesn't exist, then we mark the flag to true. Then we add a count so that we have one more unique number. Otherwise, if the number exists, which is indicated from here, the flag will be true. So if flag is true, then we return 0, which means it is not an integer number because we have found the same number earlier in the earlier iteration. So next we'll divide it by 10. So basically we extract the right number until the end. So if count equals to 9, that means I have 1 to 9 unique numbers. What about 0? Because 0 has already been marked as true. So when we found 0 in the digit, it will return 0 because the flag for 0 is true. So if count equals to 9, then we return 1. Otherwise, we return 2. That means the digit 2 field. Maybe it has less than 9 digits. So from here, we can make a conclusion. My encoding is like this. 0, which means that they are numbers that repeating twice in the number. I mean the digit repeats twice. So if the count equals to 9, which means that we have the 10 digital found. Otherwise, the 2 stands for the number that is not sufficient to form a pentagon because it has some numbers missing, which are obviously less than 9 digits. Otherwise, if it's more than 9 digits, then it will end up return 0 here. But you can mark it as 0. Then next, we'll check the way. So the state, if equals to 0, which means that the number is not an integer, we ignore it. Otherwise, we mark it as 1. So from here, basically, we are getting the number bigger and bigger. So we don't have to put the max stop maximum to get a larger number as stated in the question. So that is it. We get the product and prepare the product. So yeah, run. So we got this 932718 654. So took 28 milliseconds, which is quite fast because I use string, so it's considered as fast. So that is it about this question. So see you next week. Goodbye.